Welcome to Study Loop.
This is the answer to Chapter 21, problem number 72 from the Smith Organic Chemistry textbook. And so this problem tells us, let me see exactly what it tells us. Okay, so treatment of the molecule that I've drawn to the left here with acid forms a product of molecular formula C9H16O2 and a molecule of water. And we're asked to draw the structure of the product and explain how it is formed. And so we're given a formula for the product. So it might be helpful to start by calculating the HDI, the hydrogen deficiency index. So hopefully you remember from earlier chapters that this is going to be 2 times the number of carbons. So and actually, I'm gonna move down a little bit because I'm encountering the top of the whiteboard here. So 2 times the number of carbons, which in this problem is 9, plus 2, and then minus the number of hydrogens, which for this one is 16, and then all of that over 2 is going to give us our hydrogen deficiency index. So 18 plus 2 is 20, minus 16 is 4, over 2 is 2. And so this number tells us that we have some combination of double bonds and rings that equals 2. So just looking at our starting material here, I'm going to go ahead and say that we have 2 rings in our product molecule. And so we're not asked to draw a stepwise mechanism here, but we are asked to draw the product and talk about how it could form. And so in keeping with what we've learned in this chapter, I think what's going to happen is one of these alcohols is going to attack the carbonyl here, and so form a ring. So we're going to form a 6-membered ring. And obviously, we're not drawing a stepwise mechanism, so I'm skipping a few steps. But so eventually we'll get to this hemiacetal intermediate. One, two, three, four. Right. Okay. So eventually we'll get to this hemiacetal intermediate. And then from the chapter, we learned that a hemiacetal in the presence of acid can exchange this OH group. So this OH group. So here, let me show exactly what I mean. So there are lone pairs on this oxygen. This, as we said, is an acidic environment, and so there are protons. So that alcohol, the alcohol that's part of the hemiacetal, can grab a proton and become protonated and then leave. And so we can end up with that alcohol leaving and a carbocation forming at that carbon that's currently the carbon that has the hemiacetal. And so then this oxygen can attack that carbocation that would form. And so that will get us to an acetal. And the acetal is going to be 2 6-membered oxygen-containing rings that are joined together. So that's going to look like this. And so that's our final product here. If we count carbons and hydrogens and oxygens, so obviously there's 2 oxygens. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. Each carbon, except for this central tetrahedral carbon, has 2 hydrogens on it. So 8 times 2, there are 16 hydrogens. So this fits with the formula that we were given. It fits with the HDI that we calculated, and it is indeed the answer to this problem. Yeah, and so that's how I would go about solving this. Calculate a quick HDI just to get a notion of what you're looking for, and then think about reactivities and things that we've learned in this chapter, and think about this in terms of its mechanism. Although, again, we were not asked to draw a complete stepwise mechanism, and that's how I would go about solving this problem. And that's the answer to chapter 21, problem number 72.